live on YouTube. It's setting up the meeting.
We don't have to keep waiting for this to link off.
Oh,
And we're trying to go live on Facebook.
Dale, Eileen, Donnie, Stern, Bruce.
It's not triggering it that it's recognizing this USB.
1, 2.
Huh. Eileen Cook, Dawn Snow, Deanne Talbot.
Let's get a class.
Okay.
Oh, this-
It's not recognizing
I
it.
just flip it over.
Sorry about the little delay here.
We're getting Facebook messages. Is somebody handling that?
Yeah.
Okay.
Actually, I don't see Carol in the Zoom, so I'm hoping she's handling that. Can you
Sure.
see responses on there, Jerry?
You check.
Yeah, these are all people wanting to know how to get on Facebook Live.
Not winning the battle yet.
Okay. Are you going to turn on your camera, Laurie,
Yeah. Just,
Oh,
for the introductory comments?
there you go.
there.
There you are. Good.
Am I looking at the camera all right? I can't see me. Wait a minute. Oh. Okay, Jerry's adjusting that up so I don't have to slump like a. Okay. Hello,
Just a little bit back.
like that.
Yeah, there you go.
Okay.
Sounds about good.
How are you doing, Rick?
Susan Richards sent another message. Okay.
Who
There's been,
did?
there's been about 3 people so far.
Okay. Whoops, sorry about that.
I don't know.
Beth, for your information, I did locate the handouts, the 4-page on this first class and the 2-page on the following class, which we'll make available through Zoom and over on the Facebook page.
Gerhard, since we're getting a delay start, are we gonna time it from an hour from when we start?
Yeah, we're 5 minutes in already.
Yep, I know.
Yeah,
I may have to go with this. We may lose.
okay. Here's another option. Hold on. Use this as the. Can you still hear me, Laurie?
Yeah, softer, but I can hear you.
Good. I just disconnected the mic I was using. You should be able to find that.
Linda Payne Sheffield sent a message to UV Tag. I have a
That will pick
question.
up everything from in here.
Plug this into this one.
Why?
How do we get the Zoom audio?
It's going to come over here into there.
See why I wasn't too worried about it.
You can't figure out how to get it from Zoom directly, right?
Oh, Linda Sheffield says, is it too late to get in on the event going on now? I don't know if anybody's letting people in.
Yeah, but we're having a problem with the sound for Facebook.
Can you do it from the other computer?
Yeah, have to go in there. Show me
Well. Okay,
Will you be listening?
are you there?
Jerry's going to go to his computer and handle this stuff. He says he can't seem to do it from his phone. Although he is saying the opening prayer.
Genealogy, an introduction to DNA is what we've been using.
Linda wants to know if she has to pay to hear this thing.
Okay.
It's good to know she wants to hear it.
So you're not picking up the video? Is that what you're telling me? There's no prison. Well, we're dead on Facebook. We're not working. So we are live on YouTube. Let's go ahead, Laurie. And
Okay.
let's add 5 minutes to the end. Okay, Beth? Beth, your microphone's still muted.
Are you ready
Is that
for me
okay,
to
Beth?
get?
Okay.
Come down. He said we're dead on Facebook.
So that's where we are right now. Go ahead.
All right.
Yes. Go.
Okay. Welcome to Utah Valley Genealogy and Technology Group this October morning. We're glad to have you, and we'll begin with an opening prayer by Jerry Castillo.
Our Father in heaven, we're grateful for the opportunity to gather together to learn more how we can help with our family history efforts through the use of DNA. We're thankful, Father, for our speaker, grateful for those who can attend this meeting today, and pray that we may all be edified and enlightened about this topic, and may use it to the best of our ability to help with our research efforts to unite our families together. We pray, Father, for thy blessing to be with our speaker and to be with us this day in the name of thy Son, Jesus Christ. Amen.
Amen. All right. Well, we're thankful for Beth for being willing to join us this morning and do our presentations. The first one will be called Genetic Genealogy, an Introduction to DNA. And the second one, DNA, I've tested, now what? Okay, Beth's interest in genealogy comes from a fascination with family stories. As a child, Beth liked to listen to the stories recounted by her mother when relatives came to visit. And she started dabbling in genealogy at the age of about 14. When she entered college, she took several college courses on genealogy-related topics. She does have a BA in history from Brigham Young University with a minor in sociology. She joined the family history department in August of the following August after her graduation, and the family history library the year later. She has pursued and received her credential from the Board for Certification of Genealogy and is currently pursuing credentials through ICAP-Gen. She really loves teaching classes on genealogy topics, and she works at the library helping patrons, and she enjoys the challenges of helping patrons find their ancestors. So we'll turn time over to you, Beth.
Wonderful, thank you. Let me go ahead and share my screen. Hopefully this will all work okay. Are you seeing that okay?
Yes.
Okay. we'll go ahead and jump right in. So our first topic today is just to kind of do an introduction to DNA. It's always, for those of you who've done a lot with DNA, it's a good reminder about what DNA is and why we use it. And if you haven't had a chance to really delve into DNA, especially when it relates to family history, this will just be kind of a good overview of what DNA is. So we'll go ahead and get started. So I like to kind of break out my classes into some specific groupings just to get us kind of on track. So during our class today, we're going to start by addressing the question, what is DNA? Then we will jump into why DNA is valuable, and specifically why it's valuable to a genealogist or to a family historian, because honestly, DNA is valuable for many, many other reasons, but we're going to focus exclusively on why we are using DNA for family history. We're going to go through the different types of DNA that are used by genealogists. And then we'll take a look at some of the what I call your DNA results, or some of the things that you get from taking a DNA test. Excuse me. Apologize. Breathed in at the wrong moment. We'll talk about the testing companies that are out there actually doing testing for DNA, and then we'll talk about some other resources that can help you learn about DNA or can help you interpret your own DNA results. Sound good? Whoa, excuse me. Okay, so let's start with that all-important question. What is DNA? So what does DNA stand for? Well, DNA stands for deoxyribonucleic acid. And I always tell everybody, if you want to sound really smart, go out and practice saying that, deoxyribonucleic acid, and then you can go impress all your family and friends that you know what DNA stands for. But what DNA really is it's the genetic code that makes us us. It kind of defines your biological characteristics. You know, your height and the color of your skin and the color of your eyes and the color of your hair is all defined by your DNA. DNA itself, when you kind of zoom in and look at it really closely, it's, if you've ever heard the term a double helix, you're kind of seeing a picture of what DNA would look like on the screen. But it's just what they call bases or nucleotides that are in strings, and then they're paired with a counterpart, and then that string is twisted. And that makes up the double helix found in our DNA. And that becomes a little bit important as we get into how we use DNA with family history. There are two main types of DNA that are important to genealogists. There's what's known as nuclear DNA. And nuclear DNA is found in the cell's nucleus. So almost every cell in your body has a nucleus or a center, and within that center it has one copy of your entire DNA. And this DNA is what we just kind of talked about with those base pairs that are in that double helix, and then those double helixes are that you could stretch out and they'd be super, super long. But what happens is that DNA or that section of DNA gets smashed all together into a package that they call a chromosome. So if you can take a chromosome and unwind it, and it's a very, very long series of base pairs together, coiled together. You have a total of 23 paired chromosomes. So you have 46 total chromosomes, but each chromosome, there's 2 copies of each chromosome. Out of those 23 paired chromosomes, 22 of them are known as autosomes. And this will be important as we talk about something called autosomal DNA, meaning the DNA from those 22 autosomes. And then the final pair of chromosomes are the sex chromosomes, and they're usually referred to as X and Y. So this is a picture of DNA from an electron microscope. You'll notice that these are all the chromosomes, and the chromosomes are just simply numbered. And they're not numbered by how important they are, but they just looked in the microscope and they said these are the longest ones, the second longest ones, and so forth. So that's just the difference between the numbering, except of course with the X and the Y. Now, so that's nuclear DNA. The other half of that the other type of DNA that we work with in genetic genealogy is mitochondrial DNA. Your mitochondria are what are known as the cell's powerhouses. It's where sugar is converted into energy. Mitochondria are actually located outside of the cell's nucleus. So you have the nucleus with the one copy of the cell, but then throughout a lot of the cells, there are about 40 copies of the mitochondria. So there's actually more copies of the mitochondria than in each cell, more copies of the mitochondrial DNA than of the nuclear DNA. So like I said, there are multiple copies throughout the cell. And interestingly enough, mitochondria do have their own DNA. So those are kind of the two types of DNA that we'll talk about a lot in genetic genealogy. Now, of course, there's a lot more to DNA than what we're touching on here, but the idea is to kind of just focus on what you need to know in order to figure out how to use DNA for your family history. So the next question that I like to ask is, why is it valuable? Why are we all talking about DNA? Why is this the big thing for the last, 10 to 20 years, where DNA has kind of become very important in the genealogy community? What's so valuable about it? And the big reason that DNA is valuable right now is because it's inherited. What I love to think about is that as a family historian, as somebody who, as Lori mentioned, I love stories, but I love knowing about my ancestors and who they were. And I think it's just really, really cool to think that I have something in me that came from my ancestors. So if I have something that's part of me that's from my ancestors, I can maybe study that to help as I research and learn about my ancestors. So like I said, the big reason DNA is valuable is because it's inherited. It comes from those ancestors. Now, I mentioned earlier that we have 23 paired chromosomes. Well, one set of chromosomes comes from dad, and one set comes from mom. So 22 of your autosomes come from dad, and then 22 autosomes come from mom. And then from dad, you also get either an X or a Y chromosome. And what I failed to mention a few minutes ago is that the X and the Y, when we talk about it being sex chromosomes, define whether or not you're biologically female or biologically male. So if you have two X chromosomes, you're biologically female. And if you have an X and a Y chromosome, you're biologically male. So only individuals who are biologically male carry a Y chromosome. But because only men carry a Y, if a man has a Y chromosome, he had to receive that or inherit that from his father. So from your dad, you got 22 autosomes. If you're a woman, you had to have gotten an X chromosome because you don't have a Y because you're not biologically male. And if you are biologically male, then you got a Y chromosome from your dad. Then from mom, again, you get 22 autosomes. And then everybody has to get an X chromosome from mom because mom doesn't have a Y chromosome. So everybody gets an X for mom. And then interestingly enough, the mitochondrial DNA, those mitochondria are part of the egg, not the sperm. So mitochondria always come from mom. So you can see that we can start segmenting your DNA and assigning it to mom and dad. And then from there, where did mom and dad get their DNA? Well, they got it from their ancestors, from your grandparents and great-grandparents and so forth. Now, the other big reason that DNA is valuable is when it's compared. Because your DNA by itself doesn't tell us very much. Yeah, we can look at it and say, oh, look, this is awesome, you have DNA. But we can't even tell which DNA came from mom and dad, unless, of course, it's that Y chromosome, unless you compare it with somebody else's DNA. So the idea behind doing genetic genealogy, the very, very basics, if you stripped out everything else, is this idea that if two people share DNA, they have a common ancestor, and they have to share, enough DNA to be significant. But based on the amount of DNA they share, or how closely the DNA matches, then most of the DNA companies, the testing companies, can predict a relationship, and they'll say, okay, because you share this much DNA, or you have this, your DNA is identical in this way, in these ways, you are probably related in this way. But DNA is just suggesting that there is a relationship. From there, we have to go back to traditional family history research, compare family trees, and figure out where that common ancestor is located, where in the line that common ancestor is. But that's kind of the basic idea behind doing anything with genetic genealogy is this comparison between two individuals. Okay, so kind of just thinking that's just the basics of DNA. DNA is known as deoxyribonucleic acid. It's your genetic code. It's inherited, and it only is valuable when we start comparing it with other people's DNA samples. So let's look at the 4 big types of DNA that we talk about in genetic genealogy. First, we have Y-DNA, which they've been testing Y-DNA for about 20 years now. Y-DNA, as we mentioned a few minutes ago, the Y chromosome is only carried by men. So stop for a minute and think about, do you have a Y chromosome? Are you biologically male, biologically female? And if you do have a Y chromosome, or if you don't have a Y chromosome, think of somebody who does have a Y and think, where did they get that Y chromosome? So I don't have a Y chromosome, I'm biologically female, but I do know that I have tested my father, and he has a Y chromosome, and he got it from his father, who got it from his father, who got it from his father, who got it from his father. So the Y chromosome is inherited virtually intact. And because of this, the idea is that you can compare the Y chromosomes of 2 men and to determine whether or not they have a common ancestor on that patrilineal line, meaning that line along the paternal, father to son, father to son. Now, there are times when as the Y gets passed down, there's a mutation that happens, and that's the reason why all men don't have identical Y chromosomes, but that's what they're looking at when they compare the 2 Y chromosomes. So when 2 Ys are compared, or when a DNA testing company is trying to look at how 2 people are related, what they do is they say how many mutations or how many differences exist between these 2 people's Y chromosome. And the idea is that the more mutations exist, the further back in time the common ancestor exists. Y-DNA is tested on, instead of doing the entire Y chromosome, there is an option to do the entire Y chromosome. It's a lot more expensive. However, the kind of basic way of testing Y-DNA is by testing locations on the Y, or what are called markers. So when you go and look for or try and order a Y-DNA test, you can order either a 37 marker test, a 67 marker test, or 111. And all that means is that at a 37 marker test, they're only looking at 37 locations on the Y chromosome. 67 adds more, 111 adds more. It also adds more price or more cost. So if you're looking at your fan chart, this is who the Y-DNA relates to. And of course, the person in the center has to be biologically male. So let's take a quick look at an example of a Y-DNA matches. This is the Y-DNA matches from my father. I'm a Taylor, so you'll notice I kind of removed the names of the matches themselves, but this is from Family Tree DNA. We'll talk more about this in a minute too, but Family Tree DNA is currently the only company that tests the Y and provides a match list. But the way a Y-DNA test might be used is this. So let me show you this example. So to kind of tell you a little bit about my father, or my father's line, is we can trace the Taylors back to a man named Peter Taylor. Peter Taylor was born, according to our records, about 1660, and he was born he came from Parish Sutton in Cheshire, England. And then he died in 1720 in Chester County, Pennsylvania. And one of the key things to note about the Taylors, my Taylor line, is they were Quakers. So I found a book once where somebody actually hired somebody in England to go to Parish Sutton and start looking for Peter. We know that Peter and his brother William came together. They bought land from William Penn in 1682. They're very, very early Quaker immigrants. However, the person who was hired went back to Parish Sutton, to that area, and it turns out that there was a Quaker community there. And Peter and William are definitely named in the records in that location, in the nonconformist records. However, there's no evidence of where they came from. So they had come from some other location to that area to settle, to join a religious group. Unfortunately, this means that the next step in my research will be to look for all the Taylors in the surrounding areas, or even all of England. And for those who've never looked at the researching Taylors, there's a lot of us out there. So I've kind of always thought this might be a line that I'm not going to resolve very easily, and I've kind of set it aside. However, when I did my dad's Y-DNA test, 2 of the matches, who on the left are matches 2 and or matches 3 and 4, both descend from a man named Christopher Taylor. And Christopher Taylor, actually, they have a christening date for Christopher. He was christened on the 15th of February, 1624, so he's a generation or 2 older than Peter. And he was christened in All Saints Parish in Yorkshire, England. But he also was a Quaker who immigrated to Chester County, Pennsylvania, and he died in 1686. So I can now use that, the idea that is that matches 3 and 4, who are both at a genetic distance of 1 to my father at 37 markers, I can make the guess that Peter Taylor and Christopher Taylor were related. And I think it's very interesting to see, you know, the similarities in their immigration patterns as well. But because I know where Christopher was christened, I can now go research him and his family and see if I can find evidence of Peter and William. I'm kind of leaning towards the idea that Peter and William were his nephews. Peter and Christopher settled on opposite sides of Chester County, Pennsylvania. But I'm wondering if there was a relationship between the 2 of them, which is why my dad's got these really high level Y matches. So that's just kind of a way that you can use Y. So the DNA is just suggesting a relationship exists. It's not proving what that relationship is. That's when I have to go back to traditional paper trail research. So next I want to just mention mitochondrial DNA, or mtDNA. We talked a little bit about the mitochondria. The mitochondria are outside the cell's nucleus. They have their own unique DNA. And remember, the one key thing though is mitochondrial DNA is carried by everybody. Everyone has to have mitochondria. You wouldn't be alive if you didn't have mitochondria. However, mitochondria are inherited from your maternal line or your matrilineal line. So they come from mom, who got them from grandma, who got them from great grandma, and so forth. So again, the theory or the idea is that you can compare the mitochondrial DNA of 2 people to determine whether they have a common matrilineal ancestor. However, the one issue there's a couple issues with mitochondrial DNA. It's been a little bit harder to use for family history. First off, it mutates slower than other DNA, which means that you can have somebody with like a genetic distance of 0, and the common ancestor is still, you know, 5, 10, 20 generations back. The other big issue, at least for those of us who do anything related to Western Europe, is that it's the father's surname that is given to the children, not the mother's. And so it's harder to trace the matrilineal line through paper trail records. When you're testing mitochondrial DNA, there are 3 different regions that they test: the HVR1, the HVR2, and the coding region. It's not as important as what those are as just to understand that. Family Tree DNA, again, is the only DNA company who currently not only tests the mitochondrial DNA, but will provide DNA match lists for mitochondria. And they provide 2 different mitochondrial tests. One test just does the HVR1 and the HVR2, and one test does HVR1, HVR2, and the coding region. So it's like the mitochondrial, I can't remember what the first one's called, and then the mitochondrial plus, I think, is the one that does the full mitochondrial. So if you are looking at your fan chart, your mitochondrial DNA relates to these individuals on your fan chart. That's where it came from. So you'll notice the Y only tests for 1 line, the mitochondrial only tests for 1 line. And that's where, or we'll get into the next type in a second. The one situation that I know for sure where mitochondrial DNA turned out to be very helpful was the case of Richard III. I'm sure some of you are familiar with this story. They went looking for Richard III in trying to figure out where he was buried, and so they so there was a group who was doing this, and they ended up saying, okay, this car park or a parking lot, what we call a parking lot, was once an abbey. We think he's buried there. They got permission. They dug up some bones, but the question is, were those bones really Richard III's? And there were a lot of other tests that they did with Richard III's bones, but they did, in addition to everything else, to try and prove whether that those remains belong to the Richard III, was that they did mitochondrial testing. Now, Richard III, none of his children would have had his mitochondrial DNA because men don't pass mitochondrial DNA on. So instead, what they did is they took his sister and then found living descendants through, daughter to daughter to daughter to daughter. Though I think a couple of the living descendants were male, but again, they had to come along that female line. So they compared the mitochondrial DNA of the remains with those descendants, and that was part of the overall conclusion that those remains did belong to Richard III because the mitochondrial DNA tested. Okay, the next type of DNA I want to touch on is autosomal DNA, or ATDNA. If you'll remember, we mentioned that autosomes are the 22 paired chromosomes, the non-sex chromosomes, the ones that are numbered. And with autosomal DNA, you remember you got 22 pairs, one set of autosomal DNA comes from mom, one set comes from dad. Now, the key thing though to remember with autosomal DNA is that you don't get 1/4 of your DNA from each grandparent. Instead, your parents, the DNA of each of your parents went through something called recombination before it was passed on to you to become part of to become your DNA. What that means is that you'll get kind of a more random amount of DNA from each of your grandparents. So half your DNA comes from mom, half from dad. But beyond that, you can't ever say it's an equal percentage. Autosomal DNA is identifiable or usable for maybe the last 5 to 7 to 9 generations. There's a lot of differing opinions there in the genetic field, how far back it can be used. But once you get back 400 or 500 years, it's a lot harder to use autosomal DNA because of this recombination and randomness and inheritance. And one of the things to keep in mind is that you actually cannot have DNA from all your ancestors. If you're going back, thousands of years, it's just not possible since you only get half at every generation. And the other thing to keep in mind with autosomal DNA is that you are only guaranteed to share DNA with a second cousin or closer. So I've seen this question asked a lot. Somebody will say, okay, here's the second cousin twice removed. Why don't I share any DNA with them? It is possible, based on, again, randomness and inheritance, that the DNA that you got from the common ancestor and the DNA they got from the common ancestor doesn't overlap. Because that's the key, is that, right, if you'll only get approximately, I know it's not exact, but approximately 1/4 from grandparents and 1/8 from great-grandparents. And then those cousins have to have received somehow overlapping segments from the same grandparent in order to share DNA. So you really, there are situations where you're not going to share DNA with a cousin, especially those cousins out at the 4th or 5th or 6th or 7th generation. Autosomal DNA is measured in something called centimorgans. And we'll talk a little bit more about centimorgans as we keep going, but centimorgans, just think of it like, there's centimeters or, other, I'm trying to think, other uses of that, but it's just a way of measuring the amount of DNA that you share with somebody else. Like I said, that you don't have all the same, you won't share DNA with all your ancestors. So think about this. You actually, what that means is you have 2 trees. You have what we call a genealogy tree, that these people are all your ancestors, but your genetic tree will have fewer people on it. And this, of course, this is much more of just an example of what your genetic tree might look like. But just keep that in mind that you do not have DNA from all your ancestors. At some point, some of your ancestors fall off your genetic tree. So when we use autosomal DNA, the idea is, going back again to when I was talking at the beginning of class, that the idea is that you just say how much DNA did two people share, and then use use trees and records to try and prove that relationship. So here's an example where we have two kits for person A and person B, and I use GEDmatch because GEDmatch is free, and so I didn't want to emphasize one company, but this is just an example from GEDmatch. These two people, who actually turn out to be my father and one of my coworkers' mothers, which I thought was kind of fun to find out that we're related, they share about 50 centimorgans of DNA, with the longest segment being 16.6 centimorgans. Now, the companies start to predict that relationship as third to fifth cousins, but it's now up to me to figure out what that relationship actually is. So then I went and I looked at, my pedigree and her pedigree and figured out how my father and her mother are related. From there, I can get the actual relationship between the two is third cousins once removed. So again, DNA is suggesting a relationship. It's not proving a relationship. There is actually almost no relationship that can be proven with DNA alone. Okay, so the last type of DNA I just want to touch on is xDNA. Like we mentioned, the X chromosome, everybody has at least one X chromosome. However, it has a very unique inheritance pattern because an X can never come from father to son. So if you have an X chromosome from mom, and actually everyone does, whether you're biologically male or female, you have to have an X chromosome from mom. That X chromosome is a recombination of the X chromosomes that she got from her parents. So it's could be a bit from both grandparents. It could be all from one grandparent, which does happen once in a while, but it is much more of a kind of a randomness. However, for those of us who do have an X chromosome from dad, and again, if you're biologically female, then that X chromosome from dad could not come from his father, because an X chromosome never passes from father to son, because the Y chromosome is passed from father to son. So that means that if you're biologically female, you have an X chromosome from your paternal grandmother, and it has to be intact because there was no options for recombination before being passed down. Again, X DNA cannot be passed from father to son. What this means is if you do share matching segments on the X chromosome, you know that the common ancestor has to be along specific lines in both of your trees. So here is the xDNA chart for a female. These are the ancestors that you can share xDNA. There's no guarantee that you're still carrying xDNA from all these ancestors, but these are the only ancestors that you could get xDNA from because of that inheritance pattern. And so that's if you're female, and then that's if you're male. So you'll notice that it kind of starts to limit things. So if you're working and you're trying to figure out a match, one of your matches, and you are working with one of the companies that shows xDNA and has the chromosome browser, and you know that there is an xDNA match, that can start helping you limit which lines to focus on as you try and identify the common ancestor. Okay, so next let's take a look at some of the results that you'll get from taking a DNA test. And I try to focus on things that are a little bit universal. Let's start by talking a little bit about ethnicity. Ethnicity are the percentages. All that happens to get those percentages, so you test at Ancestry or 23andMe and it says you're 27% German, or you're 15% Irish, or you're 10% Italian, or you're 8% Scandinavian, or whatever whatever regions the testing company is using. Those percentages are generated as they compare your DNA with what are called reference samples from around the world. And each of the individual companies are compiling their own set of reference samples. And they're also segmenting out those reference samples into different groups. So that's why you'll get, for example, for a while, Ancestry was combining England and Germany, or German, what they called Western Europe, or there gets to be some odd names for those. So it gets a little bit interesting. But all that happens is as they compare your DNA with those reference samples, they give you percentages based on similarity in the DNA. But again, like I said, the DNA companies are using different reference samples, and they're growing their reference samples. So those reference samples are getting bigger, and then they're adding additional groups. But those reference samples, sometimes it's just a matter, they go out and they find people in an area who say that they have been there, and all of their grandparents, for all of their ancestors for 4 generations lived in the same region. Those are the people that are qualified to join those reference samples. They are regularly updated. I know Ancestry just went through another update, so your percentages are going to change. So I thought it'd be fun to kind of take a look. Here's some ethnicity estimates. This is me from Family Tree DNA, and I should tell you that this is from several years ago. And I tested both my parents, so I thought it'd be interesting to see the differences between us. So my dad seems to have way more Scandinavian, which is interesting. But then I thought, let me try comparing the percentages from the different companies. So here's Family Tree DNA, here's Ancestry. And again, this is from a couple of years ago. There's 23andMe, and then there's MyHeritage. And I thought I'd just focus on one location, which was Scandinavia. So according to Ancestry, and again, this is a few years ago, that I'm 29% Scandinavian. Family Tree DNA thinks I'm 39% Scandinavian. 23andMe thinks I'm 9% Scandinavian, with another 24% of broadly Northwestern European. And MyHeritage thinks I'm 4.4% Scandinavian and 3% Finnish. So what do you think? What percentage of Scandinavian am I? Well, actually, if you look at the paper trail, I am 0% Scandinavian. I have no known Scandinavian ancestors, though I have a lot of brick walls in the United States. So who knows? In addition to that, if you look at my results from Family Tree DNA as of April 2016, look what happened in April of 2019. I went from being 39% Scandinavian to being 0% Scandinavian. So what happened here? Did my DNA change? In reality, this is just a sign that the company is improving their reference samples. And that's actually a good thing. Like I said, I don't have Scandinavian in my family tree, and they've actually started to acknowledge that a little bit better. And the reference samples, like I said, the ones I was just showing you for a couple of years ago, they change constantly. It feels like every few months, oh, this company is now updating their percentages. And it's because they've updated the reference samples in the background. I thought it'd be fun to try and even just compare across the board between the different companies, and I threw in living DNA here as well. But it's really hard because they all use different terms to describe their regions. So you can kind of see that there's some variation between the different companies. The one thing to note, though, is that they are very, very sure that I'm European. And there has been a lot of people who say that with ethnicity, that getting down to continent level, they're actually really great at continent level. It's just when you start to, get more granular than that, it's a little tougher, because in reality, what does it really mean to be German or to be Irish when you think about how much movement has happened even in Europe in the last 1,000, 2,000 years? Okay, so ethnicity, to me, it's interesting. I think it's a lot of fun to look at. I think it can be helpful sometimes, especially when we're looking at adoptees. But don't worry too much if your DNA doesn't match your ethnicity percentages don't match exactly what you think they should. Or if they change over time, that's not something to be as worried about. So next, let's talk a little bit about match lists. A match list is just a list of people with whom you share DNA. Match lists are provided by the big 5 genetic genealogy companies, as are percentages. And the reason that we usually only identify those 5 companies as being valuable, because there's a lot of companies out there will test your DNA, but only those 5 companies provide match lists. And that's why we include them when we talk about genetic genealogy, because without a match list, like I'd mentioned earlier, if you can't compare your DNA with somebody else, it's not as useful. So a match list is just a list of people with whom you share DNA. You can sometimes call these a list of your cousins. Match lists they'll be organized a little bit more. If you're dealing with autosomal DNA, which is mostly what people are looking at right now, the relationship is predicted based on the amount of shared DNA. So we talked about how autosomal DNA is measured in centimorgans. So the idea is the more centimorgans that you share in common with somebody else, the closer the relationship. With Y-DNA and mitochondrial DNA, the relationship is actually predicted based on the genetic distance, meaning how many mutations are there between your DNA and somebody else's DNA. And so in that case, the lower the genetic distance, the closer the relationship. So like when you're looking at a Y-DNA results, you're really looking at those people who are like 0, 1, or 2 at a genetic distance of 0, 1, or 2 at 37 markers, or even up to 5 if you've tested as high as 111 markers. So with the match list that you share DNA, we assume that a relationship does exist. So you're going to identify the relationship, compare family trees, communicate and collaborate with those individuals, hopefully to figure out what that relationship is. If they don't want to communicate and they have enough of a tree, you can do some paper trail research. We'll see some of these examples in the next class. And then we can also use something called shared matches to help. Even if somebody doesn't have a tree, you can use shared matches to say, yeah, I think that match comes from my grandmother's line because of the other people they share DNA with. And then as you look at your match list, the relationships will be described using terms such as cousins, cousins removed, and half cousins, and sometimes half cousins removed. And you'll notice that I put in there like these short notations. A cousin is 1C, 2C, 3C. Removed is 1R, 2R, 3R. And then you can add a half to the front of it. So you can have a half first cousin once removed. Oftentimes will be shortened. So if you ever are looking at a paper or on Facebook or somewhere and somebody writes out like 1/2 1C, 1R, that's 1/2 first cousin once removed. It's a half first cousin once removed. So, which kind of brings me to this, what I realize a lot of people still don't always quite understand the difference between a cousin and a cousin removed or a half cousin. So in this particular situation, as you're looking at this, I would just start with, so here we have a situation in which John married Martha. They had children named William and Grace. William had a daughter, Elizabeth. Grace had a son, Joseph. If you want to help figure reading this. So then we say Elizabeth and Joseph are first cousins because they're in the same generation. The removes is just simply because they're in a different generation. So Elizabeth and Arthur would be first cousins once removed because Arthur is one generation removed from the relationship that's the same number of generations back to the common ancestors. And then you would have half siblings. The way I like to think about half is just that they have half as many common ancestors. So full first cousins have 2 grandparents in common, and half first cousins have 1 grandparent in common. So it's just they have half as many common ancestors. And then of course you can also have half first cousin once removed. So if we look at this chart, you can say, okay, how are Elizabeth and Alexander related? So you start by asking how Elizabeth and Anna are related. So Elizabeth descends from John and Martha. Anna descends from Martha and Frederick. So they only have 1 common ancestor instead of 2 common ancestors. So we know that makes them half as opposed to full. So then Elizabeth and Anna would be half first cousins. And then Alexander is 2 generations removed from Anna. So Anna and Elizabeth are at the same generation. Alexander's 2 generations removed, which makes Elizabeth and Alexander half first cousins twice removed. Which I know confuses a lot of people, but it's still, especially as we get into genetic genealogy, you really have to be able to describe these relationships. Okay, the other big way that DNA is being used is to solve genealogy problems. We'll get more into this in the second class today. But people are using DNA to identify biological parents in cases of things like adoptions, unknown parentage, or even what are called non-paternal events, or NPEs, or sometimes that's short. People will use the say not the parent you're expecting. These are now also being called a lot misattributed parental events, which as you can see the benefit, which are MPEs as opposed to NPEs. It's the same thing. But DNA can also provide or give ideas on how that you point to people that are related, and then you have to figure out how. So, we still need the paper trail research in there. And DNA is also being used to solve brick walls, where you confirm a hypothesis when records are missing or unavailable. A couple other ways DNA is being used. Chromosome mapping is one way. A chromosome mapping is this idea that if 2 people share DNA, let's say you and I share DNA, and we know who our common ancestor is, I can now guess that the DNA that I share in common with you, I inherited from that ancestor. And then you can use a representation of the chromosomes in order to kind of map out which segments of your DNA comes from which ancestors. This is an example I put together from DNA Painter. It's just a beginning example. And DNA Painter has a great number of explanation, clue or instructions, that's what I'm looking for, on how to do chromosome mapping if you're interested in learning more. You can also join projects. Projects are just groups of people with similarities in DNA. The one projects are mostly Y-DNA and mitochondrial DNA, but what I found is that a lot of the admins running the projects very, very knowledgeable. So if you have questions about your Y-DNA and you want some help, they're a great group to join a project, is pretty much. I think there's a couple different types of projects. There's probably more than this, but the ones I've seen, there are things like surname projects. So I joined the Taylor surname project, where they're trying to group all the Taylors and see if they can, group them into different family lines in a way. There are haplogroup projects based on a haplogroup. A haplogroup is just it's a specific code or letter that's assigned based on like a historical grouping of commonalities within the chromosome or within the mitochondrial DNA. And then there are some geographic projects out there I've seen where, like, if you have ancestors from the Isle of Man, there's an Isle of Man project, or especially smaller communities, they might be working to kind of bring descendants together and see what they can see as they compare their DNA. So there are some projects out there. Most projects are being hosted at Family Tree DNA if you're interested in looking into them or joining projects. So next, let's talk briefly about just the DNA, the testing companies themselves. First, we have Family Tree DNA. They're the first company that started doing DNA testing. They started with a Y. Family Tree DNA tests mitochondrial DNA and Y-DNA, and they provide match lists on the mitochondrial and the Y. And that's why oftentimes if you're interested in doing a Y test, you're going to want to go through Family Tree DNA because you'll want your match lists. They also do have an autosomal test. They call it Family Finder, just a different name. And they have their ethnicity estimates are known as My Origins. They also, of course, provide DNA matches for all 3 types of tests, mitochondrial, Y, and autosomal. They will provide you with what's called segment data, which you need if you want to do chromosome mapping. And they have a chromosome browser, which we'll take a look at it in a minute, as well as information about haplogroups. And like I mentioned a minute ago, Family Tree DNA is hosting a lot of the projects out there right now. So this is a chromosome browser. It's just a visual representation of your chromosomes. In this case, I'm comparing with my maternal, 2 aunts, and an uncle. And the gray is me, so I'm all of the chromosomes. And then what a chromosome browser does is it kind of paints or highlights areas where I share DNA in common with one of these 3 individuals. So you'll notice there are sections like down on chromosome 6, where I share DNA with all 3 of my mother's siblings. But there are also sections, if you look at like chromosome 3, where I share DNA with none of those 3 siblings. So that might be a sign, you know, there's some things that you can do with a chromosome browser. We won't get into much more right now. The next company that started doing DNA testing is 23andMe. 23andMe is an autosomal test. It is doing an autosomal DNA test, though it'll also provide you your maternal and paternal haplogroups. So you'll get, if you're female, you will get the mitochondrial. If you're male, you'll get both. 23andMe also provides ethnicity estimates as well as match lists. And 23andMe offers 2 different tests. They have just the ancestry test that just does ancestry, and they also have they do health data. 23andMe originally started off primarily with the goal of testing DNA for health purposes, and then they had they got the FDA involved just to make sure that they were doing things correctly, which kind of, they had to put a lot of the health stuff on hold for a number of years while they sorted out things with the FDA. And meanwhile, they really built up their ancestry service. But now they kind of have split their tests. So either you do an ancestry test or you do an ancestry and health test. They'll also do predicted traits. You know, do you have a widow's peak? Do you have dimples? Which again is just based on what scientists are starting to see in the DNA. But like, for example, I have dimples, but it predicts that I don't. But I think it's just because they haven't really identified all the locations on the DNA that would impact or influence whether or not you have dimples. And then one of my favorite things to show you is the Neanderthal percentage. And I'm in the 96th percentile for the amount of Neanderthal DNA I have, which is about 4%. So then we have Ancestry DNA. Ancestry, I think they launched their service about 2012. So they've just been around for about 8 years. They do autosomal DNA. They did originally, when they first launched the service, do Y and mitochondrial, but they don't do that anymore. However, if you tested with those, for either of those tests, the results will still be there. They also do, of course, ethnicity estimates. But then they've added something to their ethnicity called migrations. It used to be called genetic communities, which is actually really, really cool, because instead of basing their percentages off of reference populations, they have added in the information from other people's trees. So you have similarities in DNA with this group of people, and all of their trees indicate that they have people in South Carolina, or in the Tennessee, North Carolina, South Carolina region. So therefore, we put you into this region, and they call that migrations. But it's listed as part of the ethnicity estimate, so you have to know that they're 2 separate things. Of course, they also provide DNA matches, and they do have through lines. Through lines is an attempt to try and identify the common ancestors for you. However, through lines is based off of trees, not off of DNA, which means that sometimes there's some incorrect information in through lines. The one thing that a lot of people point out, Ancestry DNA does not provide segment data or chromosome browser, so they can't be used for segment mapping, for chromosome mapping, if you're interested. Here's an example of through lines where it's trying to find out how we're all, that it's saying Joseph Jacob is one of my ancestors, and this is how it thinks we're all connected through Joseph Jacob. And of course, in this case, because that Joseph Jacob's actually on my tree, but it is identifying other DNA matches who descend from that same common ancestor. Okay, so then we have MyHeritage. MyHeritage entered the DNA market, I'm going to say 2016, but I might be off a little bit. So they also do autosomal DNA, ethnicity estimates. I'm trying to remember. No, anyway, they have DNA matches, And then they also have something similar to through lines where they're going to try and attempt to find the common ancestor for you, though they don't do it by highlighting the ancestor and listing all the descendants. Instead, they're going to say, here's who we think your common ancestor is. And their tool is called the theory of family relativity. And the theory of family relativity is, again, based off of trees. So it uses all of these people's trees to try and fill in. If my tree doesn't go far enough back or the matches tree doesn't, it'll try and fill in the gaps using other trees on their website. MyHeritage DNA also does some auto clustering for you, and they do have a chromosome browser and segment data. So here's an example of the theory of family relativity where I'm trying to figure out the relationship between me on the left and match 1 over on the far right. And what it's ended up doing is adding stuff from my tree and 3 other trees to the matches trees in order to try and make the relationship, figure out what it is. But again, it's based off of trees, and that's only as accurate as the information people add. Finally, the last company we have is Living DNA. They do autosomal DNA and ethnicity estimates, and but they're based out of the UK. And so their ethnicity estimates are trying to get down to your 13% from this region of England. So it's kind of trying to narrow down in England for you. They do provide both mitochondrial and Y haplogroups as well, but again, they don't yet have match lists on those. So they are just barely, they've been working on the DNA matches for the last year or two, and they're trying to introduce something called family networks. A couple other resources to be aware of. We have GEDmatch. A GEDmatch is a third-party tool that allows you to upload kits from all companies. The one thing to know, and I don't really have a section in this class about law enforcement and DNA, but there's some other issues, but GEDmatch is the tool that's being used a lot by law enforcement currently to catch criminals, pretty much, specifically violent criminals. Anyway, so however, GEDmatch does allow you to upload kits from all companies. So if you tested on 23andMe and your cousin tested on Ancestry and you want to compare your DNA results, you can use GEDmatch to do that. They have what are called admixture tools, which are it's ethnicity estimates, but they have a lot of them. And so ethnicity is also oftentimes called more admixture, is just another term for it. They have a lot of great other tools that allow you to do things like one-to-many, one-to-one comparisons. You can compare multiple kits if you need to. Pretty much it's a lot of, I like to think of GEDmatch as a bunch of fun tools to play around with, created by genetic genealogists for genetic genealogists. And that was the original purpose of it. But you can review the matches for any kit in the database. And they have a whole number of other tools. They have one that's called Are My Parents Related? Which can be useful if you're starting to suspect that, well, that their parents might be closely related, and you can start figuring that out. They have something called the Lazarus Kit, which will let you take, if you have a deceased grandparent, but you have 5 of their children have done DNA testing, you can take those 5 kits and they'll try and reconstruct the DNA from the deceased parent. There's a couple of fun things you can do there. There's also DNA GEDCOM, which allows you to gather DNA data, analyze and compare DNA data. And they have a couple of other fun tools out there as well. DNA Painter, which is lots and lots of fun. The main purpose of DNA Painter originally was chromosome mapping. However, DNA Painter also hosts what's called the Shared Centimorgan tool. And the second class will talk a lot more about the Shared Centimorgan tool. And they also host the What Are the Odds tool, which are 2 fabulous resources as you start really working with your DNA. Here's the Shared Centimorgan tool. And again, we'll take a look at that closer later. Genetic Affairs has been another company that's come on the scene in the last few years. These just add additional tools. Genetic Affairs originally just allowed you to retrieve new DNA matches, so you didn't have to go and try and figure out which matches were new. But they also introduced an auto clustering tool, which a lot of people really like. A couple other things, there are genetic genealogy standards out there that have been put together by the genetic genealogy community. In addition, a lot of these standards have ended up with the latest edition of the Board for the Certifications of Genealogists, the standards manual. about how genetic genealogy should be used when doing professional genealogy. There's also the ISOG Wiki. ISOG is just the International Society of Genetic Genealogy. It's a great resource for learning. For those who are familiar with the Family Search Research Wiki, the ISOG Wiki just has, you know, a lot of stuff, way more stuff about genetic genealogy. And then Family Search does have a DNA site that they've put together, just familysearch.org/DNA, with a bunch of information about DNA and how it works. There are a number of great books, especially that have been published in the last few years: Genetic Genealogy in Practice, The Family Tree Guide to DNA Testing and Genetic Genealogy, Advanced Genetic Genealogy Techniques and Case Studies. Yeah, and those titles should be in the handout. Anyway, okay, so in this class we went through what is DNA, why is it valuable? It's valuable because it's inherited. It's valuable when it's compared. We talked about the 4 types of DNA, which were Y, mitochondrial, autosomal, and X DNA. We talked a little bit about what you can do with your DNA results, so that's just scratching the surface. There's so much more that you can really get into. We went through the 5 DNA testing companies. So these are companies that actually test, and the reason that they're included on this list is because they include a match list. Because really the match list is really the bread and butter, it's the core of using your DNA results. And then we went through some additional resources that can be helpful as you start using DNA. So do you have any questions?
We've had one question come up online, Beth. This was in the middle of your initial introduction to the various DNA companies. Do you find one to be more accurate than others based on your research?
So I get this question a lot: which company is most accurate? And what I'm trying to understand is, do you mean for ethnicity wise, which company is most accurate? Or for, because with the match lists really just depend on other users testing. So when it comes to which company, a lot of people ask that question: which company is the best? Which company should I start with? So when it comes to ethnicity, I don't know that there's one company that I've ever said they're more accurate for my own situation than others. But part of my problem is I don't know where a lot of my ancestors came from, because they're all from the US back to the 1600s or the 1700s. Whereas when it comes to things like match lists, what you really want to consider is database size. So for example, Ancestry does have the largest database. I'm trying to think, I know they passed 15 million. They might be up to 17 or 18. I might be wrong on the number, but I know they've passed 15 million in their database. And a lot of the other companies have much smaller databases. So you have to think database size, but you also have to think, if your DNA question is in, for example, Scandinavia, it actually turns out, and you're trying to solve a brick wall because your immigrant ancestor, you don't know where they came from, you might actually want to test with family tree DNA because that's where the Scandinavians test. So you almost have to ask, based on your research question, where are the other people testing that, you know, where are the other descendants going to be testing? Because you have to find other descendants in order to make it useful, which is a very long answer to that question. But yeah, I'm not sure that there, in terms of ethnicity, that there's one company that's been more accurate, at least not in my opinion. Any other questions?
We had a little problem with sound at the beginning of the Q&A. I guess for my thinking on multiple testing, that's most beneficial if you're actually trying to find parents, isn't it? Because all the testing companies have different databases for doing DNA matching.
Yeah.
Isn't that really where the benefit is of doing multiple testing, or is there some other one?
Yeah, so I mean, testing with all the companies, again, the idea is that you have to ask yourself, what's your purpose in testing? I mean, if you're just testing for the fun of it, then just start with one company and then play around with others. The one thing that I didn't really touch on is that Some companies will let you take your results, like I could take my results from Ancestry and upload them to MyHeritage and to Family Tree DNA and to Living DNA. But I cannot take my results from MyHeritage and upload them to Ancestry. So sometimes we'll recommend that you start with one of the two companies that don't let you upload your results from other companies, which are Ancestry and 23andMe, and then you can take those results and for a small fee, upload to other companies too. So, if you want to try out the other companies, you can, but yeah, it really does come down to what's your purpose in testing. Are you trying to solve a brick wall problem? Then you might want to test at multiple companies. If you're trying to do an adoption case, you definitely want to test at all the companies. So.
Good. If the rest of you on Zoom have any questions, please unmute your microphones and ask.
Okay, I've got a question. You talked about the number of markers as 37 or up to 111 was the maximum. What if you did the complete genome? Would that be any more, give you any more information? Now, part of the reason I ask that is because here in St. George, there's a company, it's the group, it's Intermountain Healthcare, that is doing your complete genome for no charge, but it's not for genealogy, it's for health. And they will let you know if you have a problem. For example, macular degeneration, which I have, is a genetic problem. Now I'm wondering, since they're going to do the complete genome, they won't give me the results unless there's something that they can do, and they're calling it precision medicine now, where they can correct things. Would there be any benefit to getting the complete genome done? Would it give us any more information than just the up to 111 markers?
So the key to remember with the markers is that's only when you're testing the Y. And there is an option to test the entire Y chromosome. It's called the big Y. But it doesn't actually add a huge amount in terms of your match lists. They are doing some other things with haplogroups and looking for what's called the terminal SNP and trying to build what's called a Y tree, which is, everybody's a break off of another line because there was a mutation and things like that. So there are a lot of things going on like that. But in terms of doing the complete genome for autosomal testing might be beneficial down the road, but I don't know of any company that's offering the complete genome. I didn't mention this, but you have about, probably get the number wrong. I think it's 3 billion base pairs. I always get the number wrong, but they only test about 700,000. So they're testing less than 1% for genetic genealogy purposes. And my guess is even when they're doing the complete genome, like Intermountain Healthcare, they might still be doing targeted in specific parts of the genome. I don't know enough health-wise. But right now, none of the companies would let you take that data and put it out there. And the other key to remember is that that's only helpful if other people also do the complete genome, because you have to have the comparison.
Yeah, I asked him when we went to get tested. We had my whole family, all the kids and me, tested it. I said, well, can we, we've all done the DNA thing from Ancestry and others. Oh, they said, that's all proprietary. We can't use any of that data. So each company keeps its own stuff. So so they're doing the whole thing themselves.
Yeah.
It's a group, it's with Stanford University, but the building is right here in St. George. And there are other places in the state where you can get the testing done, and there's no charge for it. It's completely free.
Yeah, a lot of times they're doing that because they're trying to run studies.
That's exactly what they're doing.
And they themselves need more data in order to run the studies.
They hope to get,
There are a couple companies, actually I think it might be Intermountain Healthcare, at least up here in, it might be the University of Utah, I can't remember who, that will let you actually take your results from one of the DNA companies and download the raw data and give it to them. Give them a copy so that they can use that as part of their study. Because what they're discovering is that they just need large amounts of data, and that's sometimes hard to get just by testing a bunch of people. But when you have 6 million people testing on a company website, you do increase the amount of data out there.
Good.
We have some more questions on Facebook.
Okay.
Casey or Cassie has mentioned that her brother got his DNA tested, and she's wondering if there was any benefit in getting mine as well.
So when it comes to who to test, that's a really good question, and it's a really big question. But kind of the standard is this: is that if one or both of your parents is deceased, you should test. Now, if both of your parents are living, for example, both of my parents are living, and I can test both of them, I cannot have any DNA that they don't have. But when you look at two siblings, you have DNA that your brother doesn't. So yes, unless you can test both of your parents, then I would test both of your parents first. But if your brother is tested, that's great. But I would test you as well if one of your parents is deceased.
Next question is for family history purposes, which company would be best for going back the farthest? I'm guessing my question is really related to the, which one has the best reference database as far as finding DNA matches?
So it really comes down to two questions. Like I mentioned, one is the size of the database. How many other users are there in the database? The largest database is Ancestry. And like I said, I know they've passed 15 million. I'm pretty sure they passed 15 million now. I'm like, when is the last time I've looked at the number size? I'll have to go look. Maybe in the break between the two classes, I'll double check. But and I believe that Family Tree DNA is the smallest database but they also have their Y and mitochondrial databases. So that's one question: is how big is the database in total? But you also, like I said, you have to ask, based on your research goal, where are the other descendants testing? And I always recommend, like anybody who's doing anything with Jewish or Europe, I recommend MyHeritage, because MyHeritage is based out of Israel. So they're very, very interested in doing Jewish DNA testing. And they're also, their kits are actually available to a lot more countries in Europe than Ancestry. Ancestry doesn't ship to a lot of countries. So you kind of have to say, okay, those are the two big questions. And again, it comes back to what's your purpose in DNA testing. And we'll talk a little bit in the other class, is that DNA is like any other record. It doesn't stand by itself. You have to combine it with other research and record strategies. And doing traditional research requires that you start with a research goal. Now, if you're just testing for the fun of it because everybody's doing it, then, maybe go for Ancestry is a good starting point because they have the biggest database out there. But, the more you get into it, the quicker you're going to see. I mean, I've tested with all 5 companies. And I've tested both of my parents with how many companies? I mean, I haven't gotten all of them yet, but I am slowly testing my parents. I've tested like 5 of my siblings. You start to just test more and more. It's kind of fun to see what kind of information you'll find out by doing that. But
one more question. Do you think a person could possibly use DNA to move back farther when you know your 4th great-grandfather came from Northern Ireland, but you hit a brick wall?
It's possible that DNA can help with that. I mean, it is 4th great-grandfather. You are getting at the edge of what might be useful, especially with autosomal testing. But when I hear it's a 4th great-grandfather, my first question is, have you identified a descendant who has the Y chromosome that belongs to him? Because Y DNA goes way, way further back in time than autosomal does. And it's not that autosomal doesn't go back in time, it's just that because of recombination, the pieces start segmenting too small to do much with. And they start to become something called IBS, which is inherited by state, as opposed by IBD, which is inherited by design, I believe. I should be pulling up my handout because I put all of the vocabulary words in the handout. So I think I'm getting those right. Anyway, but when the segments are too small, you can't tell whether they're noise or not. So that's the problem with going back further in time, is that the recombination keeps happening and breaking up the pieces.
Thank you, Beth. Laurie, you want to conclude?
All right. Well, thank you so much, Beth. That was a really good overview of all the terminology and the companies. And am I still there? Okay, just had something go on with my screen. All right, and well, thank you, and we're glad that you're going to be doing a second segment here that will take us further into what to do now after doing some testing. So thank you. And just to let everybody know who's listening that we're going to end this session, and then we'll be starting the next session within about 5 minutes. So thank you very much.
Okay. We've stopped the recording and stopped the broadcasting, I think. There we go.